Hello and welcome to my YouTube channel. Today we are going to study trigonometric ratio. I know sometimes anything on trigonometry is difficult, but it is easy when you know how to formulate the ratio on your own. It becomes easy for you to solve any problem that relates with trigonometric ratio. For instance, the problems we have here cannot be solved using Pythagoras theorem. So because of that, we need trigonometric ratio. That's the sine, the cosine, and the tangent rules. Now, you can see this triangle over here. We have a base angle and this angle at this point. So this angle here is called beta and this is called theta. Now, the angle theta is opposite to the side called A, and the angle beta is opposite to the side called B. That's where we get it wrong most of the times. When an angle is up here, it becomes difficult for us to manipulate. But that's how it works. So this is opposite for theta, and then it is opposite for beta. So here is opposite to theta and here is opposite to beta. Okay? So how do we do that? It therefore means that A is also adjacent to beta and B is adjacent towards theta. Then here remains our hypotenuse. Okay? So this is how it is labeled. So this is both adjacent and opposite depending on the angle we are discussing. If we are discussing beta, this is adjacent and this is opposite. If we are discussing theta, this is adjacent, this is opposite. So we are going to use the popular acronym SOHCAHTOA. This is SOHCAHTOA. So how this works is, we write out S is for sine. So let's consider the angle theta first. So this is theta equals opposite over hypotenuse. So this is opposite over hypotenuse. So this implies that sine theta is equal to opposite for theta is this, which is what? A. So it becomes A over hypotenuse, which is what? C. This is 1. This one is cos theta, of course we are flowing with theta first, equals to adjacent over hypotenuse, adjacent over hypotenuse. So this implies that the cos of theta is equal to, this is the adjacent and this is the hypotenuse. So it becomes B over C. This is what? 2. This is the ratio 1 and this is ratio 2. Then ratio 3 will be tan. That is T. Theta equals to opposite over adjacent. So this becomes tan theta equals opposite for theta is A, all over adjacent for theta is what? B. So this is what? Ratio 3. Then ratio 4, we go back again to this using beta. So we now write the sine of beta is equal to the same thing, opposite over hypotenuse. But in this case, the sides are changing. Look at now, this is the angle we are considering. So the opposite becomes this. which is B. So this is now the opposite, B over what? Hypotenuse, C. So you notice that the hypotenuse never changes. It remains constant. Of course, by trigonometric, or rather Pythagoras rule, you should know that the hypotenuse never changes. So this is our fourth ratio. Then the fifth will be cos beta equals to, we replicate this again as adjacent over hypotenuse. So this implies that cos beta is equal to, adjacent to beta is A. So we write A over hypotenuse, which is what? C. So this is what? The fifth ratio. So you can see the flow. It's very straight and direct if you can understand it this way. So, in order to save space, I want to do the sixth ratio here. For the sixth ratio, we have TOA, which is tan of beta equals opposite over adjacent. Opposite over adjacent. So tan beta is equal to opposite over adjacent. Beta is opposite to B and adjacent to A. So this is going to give us B over A. So this is the sixth ratio. So this is how they are formed. You can pause the video, replay to understand the concept. So now let's move straight into this question. Now we have the angle 35 degrees opposite to x. X is not given, but the hypotenuse is given. According to the question, we say find the value of x on the figure below. So this is the figure. This is another. So let's draw a line. Now to solve A, what are we going to use? First of all, what you do is, you don't come scouting around this to check what to use. You just invoke this SOH CAH TOA. So we say using SOH CAH TOA. Using SOH CAH TOA, we check. Okay? Sine will give us opposite over hypotenuse. Hypotenuse is given, opposite is x, which we are looking for. So probably we should use sine, not cosine or tangent. Maybe they could go, but you have to check first. But since for me, I found that sine can work, that is SOH is going to solve this problem, I don't go further. I use this. So we now say sine this 35 degrees is equal to opposite over hypotenuse. Opposite over hypotenuse. This is opposite to this. So this is going to be x over 7. So what is sine 35? If you check on your 4-figure table, sine 35 should be giving us 0.5736. So this should be equal to x over 7. So what we do now is we cross multiply. In cross multiplying, 7 comes this way to multiply this, and x comes this way. There is an invincible 1 here. So x times 1 is x equals to 7 multiplied by this should give us 4.02 meters. That is approximately. Then for the second one, I look at it again. The angle is this way. This is the opposite. This is the adjacent. So by SOH CAH TOA, I know that opposite over adjacent is tan. That is TOA. So just for clarity, like I said, you have to check. SOH is opposite over hypotenuse. Hypotenuse is not given, so we will not profit from using SOH. Then CAH is adjacent over hypotenuse. We have adjacent, but there's no hypotenuse, so we are not going to profit from using that. So we move straight to what? Tan. So to solving B, we have tan 45 degrees equals opposite over adjacent. This is adjacent. 45 degrees is adjacent to this and opposite to this. So this becomes x over 15. Tan 45 from your 4-figure table or your calculator should give you 1. So this is equal to x over 15. This is also over 1. So we cross multiply. So this comes this way. X should be equal to what? 15 cm. That is the answer. So do well to go through the videos again. You can share the videos, like, and don't forget to subscribe for more videos. Thank you and take care. Bye bye.